In this video, you're going to learn how to build an advanced Retrieval-Augmented Generation system in order to chat with a custom PDF file. We're going to be using Llama 3 and other open models in order to create our RAG application. Let's get started. If you want to follow along, there is a complete text tutorial that is available for ML Expert Pro subscribers, and it is within the bootcamp and then advanced RAG with Llama 3 in Langchain. Here you can find the complete text tutorial along with explanations for each of the separate parts of the tutorial along with the source code that is required to reproduce the results. So please consider subscribing to ML Expert Pro. Thank you. While there exists a lot of approaches to building an advanced RAG applications, in this video I'm going to show you how you can use open models and Langchain in order to build your own advanced RAG. We're going to be using Llama 3 along with other models for embeddings and reranking, and we're going to be wrapping everything within a nice Langchain chain in order to chat with a custom PDF file. So here is an overview of what we're going to cover. First, we're going to have a look at the essential architecture and the main components of that architecture. Then I'm going to show you how you can build your knowledge base. This is one of the components. Then we're going to have a brief look at the Reranker that we're going to be using. And finally, we're going to wrap everything within a Q&A chain from Langchain. And we're going to initiate our LLM, which is going to be using the Groq API, and it's going to be Llama 3. Our advanced RAG application is going to be built using three main components, and those are the knowledge base, the Reranker or ranker, and the large language model. In our case, the knowledge base is going to be containing a couple of subcomponents. First of those is going to be the parser, and its job is going to be creating some structured information from a PDF file, at least in our case. This structured information or text is going to be then processed by a text splitter, which is going to be creating chunks of the text. And then those chunks are going to be created into an embedding vectors. And this is going to be done using an embedding model. And the output of those vectors or those vectors themselves are going to be stored into a vector database. The vector database that we're going to be using is going to be also responsible for finding similar or relevant documents based on our user's query. And then these documents are going to be passed to our ranker or reranker. Its job is going to be to do a pairwise ranking and thus filter out irrelevant documents and sort the more relevant documents on the top. Then these documents are going to be passed to our large language model along with a custom prompt that we're going to be creating. And then the result is going to be processed by our Langchain chain and returned to the user. The largest component that we are having in our RAG application is going to be the knowledge base, and the main job of this knowledge base is going to be extracting some structured data from a PDF in our case, and then we are going to split the data or the text into chunks. And after those chunks are created, we are going to be using an embedding model to create embedding vectors for these chunks and then save them into a vector database. Then we are going to be doing reranking, and this is done in order to get a better sorting or ordering of the relevant documents that are provided by the vector database based on a user query. And this must give you more relevant results or filter out irrelevant results as well. But this is a very important component, since if you don't get relevant results after the reranker, then essentially your LLM would not be able to respond with a sufficiently good information. And the final component is going to be the chain, that is going to be a question and answering chain, which is going to be using Llama 3 in Langchain. And this is essentially the front end or the front facing part of your application or user facing part. And this is actually the combination of everything that we have as components: the knowledge base, the reranker, and then the large language model, in our case Llama 3. And of course, this requires some prompt engineering, and yeah, there are a lot of templates or default prompts for those chains, but in our case, I'm going to be using a slightly tweaked version for our rack application. So to build our rack application, I'm going to be using a Google Colab notebook, and in it, I'm going to install all of the required dependencies. We're going to be using Langchain, so I'm going to install that along with one chain Groq, since we're going to be using Llama 3 via the Groq API. Then I'm going to be using LlamaParse to parse the document, Qdrant client, since we're going to be using this vector database, unstructured markdown loader, FastEmbed for the embedding, and FlashRank for the Reranker model. So we have a lot of imports here, and pretty much the only API key that we are going to be needing are for the Groq and then for LlamaParse, of course, since LlamaParse is not open source. So the document that we're going to be using is provided on Google Drive, or my personal Google Drive, and for the document itself, here is it. This is the meta reports first quarter earnings or results. And the important thing about this document itself is that it is pretty complex. It has some text formatting, it has a lot of tables, a lot of structured text, and some formatting. And we'll see how well LlamaParse is going to be able to parse these type of documents. While Langchain allows you to use a lot of different PDF loaders, I found that LlamaParse is providing pretty much the best possible responses or results for a bit more complex PDFs. In our case, we're going to be working with a financial document, and in those types of documents, you often see tables or figures or some very intricate formatting of the text, like bullet points or text or tables within tables and text within tables, etc. And those types of structures need to be formatted a bit better. And in order to do that, LlamaParse is, I think, doing a great job with that. To use LlamaParse to prompt our document, you need to essentially instantiate a client LlamaParse. In here, you need to pass in your API key. I'm going to specify that I want a markdown document as a response. And here is some parsing instructions. It is pretty much a very basic prompt that I want this parser to actually extract some text and some very well-structured data. We're giving it a max timeout for the API, and then I'm calling the await data. This is essentially an asynchronous task, and I'm pretty much just giving the PDF file that I've shown you previously. And this should take roughly 2 to 3 seconds in order to parse the complete document. And since this is just a single document, I'm going to show you the response. And from that, you can see that this is indeed a very nice formatted markdown file. In here, we have the parsed table, which is great. And we have some bullet points, etc. The response here is not visible as good as it is in the original markdown file. The markdown parser or displayer presenter within the Google Colab is a bit buggy, and the response is actually much better compared to what we can see here. So I'm pretty happy with the responses from LlamaParse. And the final step right here is to actually save the markdown file as a file within the data parse document. And since we're going to be using this in a bit. Next, I'm going to show you how you can create essentially vector embeddings for the document. And the first part is going to be to actually load the markdown document using the unstructured markdown loader. And then from that loader, I'm going to be essentially creating a recursive character text splitter. This will get chunks of 2048 characters, and it's going to be splitting those with some overlap of 128 characters. And this is going to be essentially splitting our document into 10 different smaller chunks or subdocuments, if you will. And here we have the first chunk. You can see this is essentially equivalent to the 2048 characters. So this is a sample chunk. And in our case, I'm going to be using FlagEmbeddings, and those embeddings are pretty much specific to the English language. They have multilingual version, I believe. But in our case, I'm going to be using the base model. And this is pretty, roughly speaking, very optimized model. It's only 220 megabytes. And it appears to be doing some great jobs on the embedding side, at least according to the leaderboard for the embeddings that I've seen from Hugging Face. And the fast embed embeddings is actually using, if you look over here, the on NX essentially optimized version of the embeddings. And I've run this notebook on CPU. So it appears to be working very fast, and I'm pretty happy with the responses. It takes roughly 1 to 2 seconds in order to create the embeddings, which is very fast for such an embedding model, and I'm happy with that. And from here, I'm actually using the Qdrant vector database, and this database is actually, at least the client for it is open source, and it is available on GitHub. They have a cloud provided version as well. But in our case, I'm going to be just storing the database into a local path for the database. You need to also provide a collection name. In our case, I'm going to be specifying just document embeddings. And then I'm going to be passing in the documents and the embeddings. So the embeddings is actually going to be just the embeddings model right here. Next, I'm going to try to essentially prompt the database, and you'll see that with these 10 documents, it takes roughly 500 milliseconds in order to get the similar documents. And what is the most important innovation from Meta? And this was essentially the query that I've tried out. And here you can see that we get the responses. I've just trimmed to the first 256 characters. And as well, you can see that the responses contain score. And as essentially the higher the score, the more relevant the document, at least according to the, I believe that the similarity search is using probably cosine similarity under the hood. Not really sure about the quant implementation, but probably something like that. And those types of measures essentially can give you a score between 0 and 1. And if the score is close or 1, essentially you have perfect match or very much higher similarity compared to lower scores. Next, I'm going to convert this database of our embeddings into a retriever. And this retriever we're going to be using for the Langchain chain in itself. And the keyword that I'm specifying here is that I want this to return the top 5 responses. And again, you can take a look at the documents, and you can see that at least with this retriever invoking, you don't have any scoring, at least with this approach. So next, I'm going to be adding the Reranker. And as I've stated previously, we're going to be using FlashRank. And this is an open source library that is essentially providing a lot of Rerankers. And here I'm going to be using the macro Reranker. And this one, it is only 22 megabytes, and it is very fast as well. And you can see that essentially how this works is this is a wrapper or a decorator on top of the base retriever. And then you are essentially passing in the Reranker here and the base retriever. And just invoking this, you now get re-ranked documents. And yeah, you see here that it takes roughly 3 seconds actually in order to get the response for this query. And these are the results. You can now see that the Reranker is actually again containing some metadata relevant score for the ranking of the documents, which is great. Next, we are going to be looking at the large language model. And in our case, again, we're going to be using the Llama 3 70 billion parameter model, and we're going to be using the Groq API. And here is pretty much the custom prompt that I'm going to be providing to our chain. And this is going to be taking the context, which is going to be coming from the Langchain relevant documents. And the question, this is going to be the question that we're going to be providing by the user. And this is essentially the prompt. You can have a look at it. It's pretty standard. I just want the model to have a look at the context that I'm providing, and I want it to provide some helpful information if applicable. And I don't want this model to hallucinate. And yeah, this is a big problem with those types of RAG applications. And you can't really be sure if or not the model is hallucinating, but still those types of prompts are somewhat helpful when you try to mitigate this risk. But be aware of it. And finally, we're going to be creating this chain. So for the chain, we are going to be using the large language model, essentially the re-ranking on top of the retriever, the prompt, and then I want this to be verbose, and the chain type is stuff. So essentially this will tell the Langchain library that we want everything to be put into the prompt along with the relevant documents, and I'm going to show you what this is doing under the hood, thanks to the verbose true. And here is the first question that I'm passing into the question and answering machine or our RAG application. What is the most significant innovation from Meta? And from here, you see that this is essentially getting the prompt as I've told you thus far. And this is essentially the context for the top 3 documents that we are providing here. And based on that, you see that the response from Llama 3, and this, by the way, took roughly 7 seconds. The most significant innovation from Meta is the new version of Meta AI with Llama 3, which is mentioned in the quote from Mark Zuckerberg. Additionally, the press release highlights Meta progress on building the metaverse. And let's go to the PDF, original PDF. And here you see, at least at the start, it's been a good start of the year. The new version of Meta AI with Llama 3 is another step towards building world's leading AI. And then steady progress building the metaverse as well. So it appears that the model picked up, at least according to the document and of what I've read, it's picking up very well what is happening under the hood. Then I'm going to essentially turn off the verbosity. What is the revenue for 2024 and percentage change? And here I'm essentially going to be asking the model to extract some data from this table. And the revenue is this number, 36,455. Let's see, 36,455 million. Is this in millions? Yeah, it says it millions. All right, so it picked up even that this is actually in millions. And the percent change year over year is 27. Yeah, so you can see that this is actually correct as well. Great. Then what is the revenue for 2023? The revenue for 2023 is 28,645. That is correct again. And this is increase for the additional information. So it is actually providing us with a relevant additional information thanks to the prompt that I've given it. This is a bit more verbose, of course, but in our case, I just want to have a look at whether or not the model is going to be hallucinating some data. So how much is the revenue minus the cost and expenses for 2024? Calculate the answer. So this is essentially going to be this number minus this number, and this should, I believe, be the result. Let's see. Yeah, it appears to be doing a good job in that. This is correct, at least appears to be. And let's see now pretty much the same question for 2023. So 28 minus 7. Yeah, it appears to be doing a mistake right here. It is 28 minus 7, and it should be, sorry, it should be 28 minus 21 something, and the result should be 7. 7, 2, 2, 7. Yeah, it actually made a mistake here. Okay, so this one got it wrong. What is the expected revenue for the second quarter of 2024? The expected revenue for the second quarter of 2024 is the range of 36 to 39 billion. So let's see if we can get this from the document. Yeah, the total revenue to be in the range of 36 to 39 billion. Okay, so it appears to be correct. The quote is correct. What is the overall outlook of Q1 2024? The overall outlook is positive. According to Mark Zuckerberg, it's been a good start of the year. The company reports strong financial results with revenue increasing by 27% year by year to 3646 billion. Net income has also increased by 117% to 12.37 billion. Okay, this again seems very reasonable, and the chat with the document appears to be working quite well. So this is it for this video. We've seen how you can build an advanced RAC application in order to chat with a custom PDF file. We've seen how you can create or build your own knowledge base for your RAC, how you can use a Reranker, and how you can use Llama 3 in order to essentially wrap everything into a Langchain chain or a RAC within Langchain in order to chat with a custom PDF file. Thanks for watching, guys. Please like, share, and subscribe. Also join the Discord channel that I'm going to link down into the description, and I'm going to see you in the next one. Bye.